Okay, hi everybody. Thank you for joining the Dapr community call for November 2nd, 2021. I'll be the community call host tonight. My name is Nick Greenfield and I'm a Dapr maintainer on the docs repo. We have a pretty full agenda tonight, so we're going to get right into it. We're going to start off by talking about the preview of what you can expect in the 1.5 release. Then we're going to talk about the new criteria for stable components, which is components formerly known as GA components. We're going to have a brief update on the status of the configuration API building block. And then we're going to do a deep dive into the resiliency policies across all building blocks. That's proposal that's live on GitHub right now. And then lastly, we'll have a demo of the Unix domain socket support that was recently merged into the Dapr repo. And if there's time, we'll have an open discussion for anyone to ask questions. The participants are all muted, and video screen sharing is disabled by default. If you do have a question at any point, please feel free to add your question into the chat, and we'll try to make sure that we address that question as we go through the topics throughout tonight. And so with that, I will kick it off to Artur for the preview of the v1.5 release.
Okay, hello. Thanks, Nick, for the introduction. Can you go to the next slide, please? Okay, so there will be some new features in 1.5. So I will go through the highlights here. The big one for sure, the biggest one for sure is State Query API. And it will gonna be available as v1.0 alpha 1 version. You can query using a document type of query where you pass this JSON document, and you can have operators like equals or greater than, lower than, and you can pass attributes that are values in the document that is saved through the Dapr state API. So this API is specifically for state saved through Dapr. You can also have sorting, and you can sort by multiple attributes, and you can also sort by descending order. To begin with, we're going to support this in MongoDB and Cosmos DB. These are going to be the two first databases to support this. Later on, we're going to have Redis support as well, and there's a documentation explaining how you can add support for Query API into your state store that you use. This has been one of the most requested features of Dapr, even before Dapr went 1.0. So we're really happy to see this happening. Thanks to Dimitri that took this issue and designed for it, collect feedback, and now it's implementation stage. The SDK changes, though, will happen in 1.6. So in 1.5, you're going to be able to query this directly through the HTTP API or gRPC API. But there will not be SDK support yet. We're going to add that in 1.6. Next slide, please. Another thing that we noticed is that Postgres was not conformance with the state store API. There was an issue that surfaced this problem. So somebody made, an external contributor made the change to fix PostgreSQL, add it to the conformance test, and now you can actually use Postgres, for example, for active state store, and it will work as expected. So that was an important fix in 1.5. Next slide, please. Another important feature is for Azure Service Bus, there is support for metadata, where you can send metadata, or you can also receive metadata as part of an event. So all this is done through the usual metadata for the events that we have in Dapr PubSub, and there's a list of events of attributes that you can pass, like message ID or session ID, like in this example, and some that you receive as part of your cloud event. So that's the issue. If you want to take a look at that, that's an example of how you can use metadata to augment the feature set that the component supports. So it's not limited only by the Dapr API. You can actually extend that if you want to use something specific to a component. So there was a good example of that. Next slide, please. And I didn't want to mention all of that because there are so many changes in 1.5. But 1.5 was a release focused on quality, something that we usually call fundamentals in the team. So you're gonna see improvements in PostgreSQL, like I mentioned, Apache Kafka, MongoDB, RabbitMQ, MySQL, multiple Azure components, AWS components as well. I think it was SNS. There was a feature added to SNS, GCP components. So we saw enhancements across the board, including Dapr runtime. And again, these are things you're gonna notice in the quality of when you run the component in your production environment, for example. So that was the main focus of 1.5. In 1.6, you're gonna see a continuation of that, but there are gonna be more features. So that is something that you can expect coming up in 1.6 as well. Can you go back? Go next? Okay, next. Yeah, so the key dates are November 3rd for code freeze and November 11th for the release date. Code freeze, we're gonna assess tomorrow how what are the open PRs that we have. If you wanna postpone the code freeze to get something important in. And after that, depends on how the release candidates go. We might or might not move the release date from November 11th to something else. All based on the validation steps. So sometimes we catch issues in the release candidates. I would say many times we do, which is a good thing. It means we do have a very strict quality bar for our release process. So usually we go through like multiple release candidates before we actually cut the release. So let's see how it goes this time. Next. And also another very important milestone for this release is that we proposed a new criteria to stable components to the steering committee, and that was approved. So basically, the problem we had is that the original criteria to GA components, general available components, was that the component should be used in production by at least 2 different users before it could be called GA. And some users were requesting, oh, I don't want to use a component production before it's generally available. So it became kind of a chicken and egg problem. To solve that, we revamped the criteria for components, for stable components, and we also renamed from GA to stable. So what we used to call GA is now called stable. So I'll go through some details now in the next slides. The alpha components remains unchanged. So if you want to contribute to a brand new component, nothing changes. You still create a PR with the metadata configuration, then create a PR to Dapr. The alpha component can have bugs. It doesn't have to have any tests. You can break the API, so you might have breaking changes to alpha components. Although we do avoid in some components to have breaking changes in Dapr, it's usually possible if you really want to have breakages in alpha components. So that does not change at all. Can you go to the next slide, please? The beta components differ from the alpha components in the sense that they have to pass the conformance tests, and that gives you some level of quality and some level of validation that this component will work with the expected behavior of a given API of the building block. The conformance tests are black box testing, where we have tests that test expected behavior for the APIs without considering any individual behavior of each component. So any specific behavior per component is ignored. We validated the generic behavior, the common behavior for the building block. And again, better components can also have incompatible changes. And now is the change for the 1.5. For stable components, we're introducing a new type of test for components contrib. We call certification tests. It is in addition to conformance tests. The component in stable also have to pass certification tests. And the focus of certification tests are functionality of the particular component, not necessarily the generic behavior. The common behavior is set by conformance test that remains. This is specific behavior of your component that requires specific knowledge of how the component works. And resiliency. Does it have some support for fault? For example, if a connection goes down, will the component reconnect without requiring the sidecar to be restarted? So there's a higher level of guarantee in this particular level going forward. And there's no requirement that anybody is using your component before you can make it stable. So if you have a really high bar and you want to work on your component, you can graduate from alpha to beta to stable without waiting on anyone to use it. The component will be maintained by Dapr maintainers. So when you contribute, that's another important change here. When you contribute to a stable component, it does not mean you are the one supporting it going forward. Maintaining components is still a responsibility of the repository maintainers. So we don't expect each component to have individual maintainers outside the Dapr organization, as everything is under Dapr, maintained by Dapr maintainers. And the other characteristics is still the same. It has to be well documented and tested, and if there is any vulnerability or bug fix, we will release a patch for the runtime for that. Next. And that's it. That's everything I have to present about 1.5 and the criteria to stable. Thank you very much.
Thanks, Arthur. I'm not seeing any questions in the chat, so we can keep moving. I'll hand it over to Yaron, who will provide a status update on the configuration API building block.
Yeah, thanks, Nick. Can you hear me?
I can, yes.
Okay, great. First of all, I want to chime in on what Arthur said about the state query API. That is one of the most highly requested Dapr features ever. You know, we released Dapr in October 16th, 2019. And I think on October 17th, like 24 hours later, people started asking, where's the query state capability for Dapr? So yeah, like it's been in the works for like 2 years, but I'm really glad that it finally arrived for 1.5, and thanks Dimitri for taking up the the mantle and doing this. So yeah, thanks. So let's talk about the configuration API a little bit. That's also something that's been in the works for less time than the state query API. We've been discussing configuration API for I think a good 5 or 6 months now, but finally it's come to completion. Thank you, Lawrence from Alibaba, for driving the design. Well, actually, I want to thank Sky from Alibaba, who's no longer at Alibaba, I think, for starting this. And then Lawrence took over and really brought this to completion with PRs that span both components contrib, the documentation, and Dapr. So thanks, Lawrence, for that. And this is a feature that we want to get in for 1.5. Currently, the situation is we've moved it to 1.6 because we don't have documentation in place, but we think we can actually get this done if Mark Fussell, the doc maintainer, and I basically take this up during next week. and bring the docs in place. And so we're going to move this back into 1.5 and really try and make it a 1.5 feature. It's really important to note that this is an alpha level API, so this is not going to be production ready or recommend for production in 1.5 or 1.6 when we do incorporate this. So this is going to be an alpha for quite some time, really until we get user feedback and until the API makes it to a beta level feature. And so I think we have macOS as the preliminary component that's going to support this, and also Redis. And this is only going to have gRPC APIs to begin with. So you won't be able to use the configuration API from HTTP, just from gRPC. And that's because we weren't able to find a really good way to call back or notify an app when a configuration item changes for HTTP. But this is actually very native for gRPC. Using the bidirectional bindings API that we designed. So the current status of this is we're trying to get this into 1.5. We'll know better next week. So keep posted on the 1.5 release issue. We're going to update there. Again, I have a pretty good feel like this is going to make its way into 1.5. It just depends whether or not we can get documentation in place. Regarding the implementation in the Dapr runtime, the PR is actually approved. I'm going to approve it, today or tomorrow officially so that we can merge it. So really, it's all in documentation. We don't need implementation in SDKs to release this. So the implementation in all of the SDKs is going to come afterwards. Hopefully we can get most SDKs to support this before this becomes a GA feature. If there are any questions, you can ask now in the chat or unmute yourselves or ask to be unmuted on the Zoom call, and I can take questions. If not, we can move on to the next subject.
Not seeing anything yet, but we can always come back to it if something pops up.
Yeah. Okay, thank you.
Thanks, Ron. Okay, moving right along, we're going to hand it over to Phil, talk about resiliency across all Dapr building blocks in the proposal that's live on GitHub right now.
All right, hey everyone, can I grab the screen sharing?
Yes, you may.
All right. Are you able to see my screen?
Yep.
All right, so here we are. Here's the proposal for resiliency, and again, emphasis across all building blocks. And it's important to have that emphasis because there have been a couple issues particular to specific features of Dapr. And so what this one aims to do that's a little different is take out several birds with one stone. So getting into it though, the first thing we want to be very clear about what we're trying to do here is our design goals and what we're trying to solve for. So this one specifically solves for timeouts, retries, and circuit breakers, right? So there are other patterns around resiliency that we're not tackling in this, like bulkheads and throttling. Those could be done in a future proposal for sure. And I'm not going to go into all the bullet points in this. I encourage folks to read this, and I think just to state up front, our main goal is like the call to action here is to get folks to comment on this if they see an opportunity to improve this proposal before we implement it. And I believe we're going to start implementing it in the very near future in 1.6. It's another highly anticipated feature set. So getting into the design, the first really big thing to point out is that we recognize that configuring resiliency is not a brief, like succinct thing. It's going to take a lot of lines of YAML, and thus what we decided to do was to create an entirely new CRD separate from configuration, separate from the components, just as a specific area for configuring resiliency. And not only was it for the sheer size of how big those configurations can be, but it also kind of makes sense from a separation of duties perspective. So in other words, like you might have, architects or SREs that are primarily responsible for resiliency of an application. And so they have their own isolated kind of sectioned off configuration that they're responsible for. So that's kind of the main reason there. We'll get into the 3 sections that are part of the CRD. The first one is policies. So this is, as it says, how you actually go in and define the policy types, the 3 types that we talked about. So for timeouts, it's very simple. All you really have to do is define a timeout format, which is like, could be like 1s for 1 second or 500 ms for 500 milliseconds. That's all there is to it. Very simple. For retries, still very simple, but there's a little more involved. So mainly we support all the features of this package right here, this backoff package that's in Go. And the main 2 policy types for retries are constant and exponential. And really all that determines is the time that it waits before it does another try to do the particular operation that you're trying to do. And so obviously with constant, it's a constant interval between, whereas with exponential, there's a mathematical equation to figure out the next duration between it makes that next call. And typically it's an increasing, hence the term back off, it's an increasing timeout. So I'm not going to get, like I said, I'm not going to get into all the different configuration values, but here they are. And for the most part, I think we're using some of this this component in Dapr already. So it's really just piggybacking off of piggybacking off well-established components. So getting into circuit breakers, this is where things got a little more interesting and not as straightforward. So the big thing to really take away with circuit breakers is that they maintain an internal state that is long-lived, right? So it would be kind of a bad idea to take one circuit breaker and apply it to a Redis component and a Cosmos DB component, for example, because once the circuit breaker were to trip, and that's the whole point of a circuit breaker, is to, once you establish that a particular backend thing that you're calling is unhealthy, to just decide to give up. Like, don't even bother trying to call it for some amount of time, and then maybe try it later on and see if it's healthy again. And this prevents kind of like the thundering herd, that can take down the system. So that's in a nutshell what circuit breakers are. So they like, as I was kind of alluding to, they maintain the state, and so they kind of have this one-to-one relationship with a given component. And so you just can't say apply a circuit breaker policy to all components, because what would happen is if Redis were to go down in that example, it would trip and go to this open state, and then it would also take down Cosmos DB traffic, and even though Cosmos DB was completely healthy, right? So this is something one has to keep in mind when configuring circuit breakers, is that kind of one-to-one natural relationship between the component and the policy. So again, we're using a well-established this Go breaker library for all the settings, and you can configure it as such. For trip, which is kind of every time your call happens to error, this particular trip function is called. And much like a previous proposal, we use something for our pub sub routing proposal, we used a language called cell, which is just a library that's used for evaluating expressions. And so the default expression is, if I have 5 consecutive failures given a particular operation, that I will then trip that circuit breaker and call it unhealthy. And you can override that default and define your own expression using these variables, right? Not going to get into them, but I think for the most part, an expression like this is going to be a pretty good default for most use cases. So getting into the next section, so this is like the second section of that CRD. And I probably will actually just at this point skip to the YAML, because I believe it's a little more tangible. I would encourage folks to read each of these things, because I think there are subtleties for how the building blocks behave for each of the building blocks. For example, when you're doing service invocation under services, what'll happen is it will trip not just the entire service, but a endpoint that happens to be part of the load balancing that Dapr performs, right? So that makes sense, right? You might have an entire application, there are 10 endpoints, and only one of them goes haywire. You don't want to take down all 10, you just want to take the one out of service. And so that's kind of a detail there that needs to be considered with this. So the other is a little more straightforward. Actors is interesting. It gets into the scoping of how actors work, but I'll go ahead and move on. This just lists out the fact that part of, the Dapr API as it in itself has lots of different operations that you might want to apply resiliency policies to. And so this is just kind of enumerating what those are, just so that people have a reference, and it's really nothing more than that. Moving down to the YAML. So this is kind of what it would look like. We have, in this proposal, have said it probably makes sense to implement this in 2 different phases. So the first one is basically implementing the policy definition. So going through that real quickly, you've got the timeouts. Like I said, it's a very simple timeout expression. For the retries, you've got the difference between the constant and the exponential. And depending on which one you choose, there are different properties that you can set for them as above. And really, one thing to call out too is that all these policies are given a name, right? So you'll see how they're applied below, but you can kind of see how this one applies to a pub sub. This one might be a case where you don't want to give up. You have to just keep retrying until the thing succeeds or the application is shut down. So these are all given kind of names that are applied to the building blocks. For circuit breaking, it talks about what I alluded to, is that there's kind of this one-to-one relationship between the policy and the building block. And because of that, what's really happening here is when you're defining one of these things by name, it's actually, this is a template. So you can think of this kind of like the factory pattern in the Gang of Four book, right? So it's a template to create the policy for a particular building block, and Dapr will do that automatically as it needs to. So for the building blocks, we have the different sections, the different types of building blocks, obviously. So you've got service and vacation. The next key down, if you will, is the app ID of the service that you are calling. And then you're basically at that point applying the timeout, retry, and circuit breaker by name to that particular service. And you can see from here on out, it's basically the same pattern. For actors, with actors, there's a few more properties. You can read about them above. I'm not going to get into some of that detail. But as you can see, for components, I can say state store 1 has, I just want to treat it generally. So I have a general set of policies that I'm applying there. And then for, if I have 2 different pub subs, I'm applying basically the same retry and circuit breaker policies to that. And routes is an interesting one. So for pub sub, really what we're talking about here is publishing. For routes, it actually covers both consuming from a pub sub and also input bindings, because really those both funnel to this concept in Dapr called a route. And so that's just how Dapr actually invokes your application, and really your application is kind of none the wiser for the most part if it came from a binding or if it came from pub sub, other than the fact that you get a cloud event or some custom payload from the input binding. So hopefully that makes sense, but route is kind of like basically how Dapr talks to your app, that flow. Now we're getting into the phase 2 stuff. So this was kind of, you can think of these as sane defaults at the component level. But let's say there are particular scenarios that your application has that you need to apply different policies for. So one example might be, I'm calling a different service and I'm requesting more than 1,000 items from like a search call, for example. And I know because I'm requesting more than 1,000 items that I might want a longer timeout, and I might be a little more generous with my retries, right? So here's a case where I'm applying particular items out of the request. And again, this is using cell that we talked about above in order to basically match on this rule. And once this rule matches, we know to apply these policies to it. And so this will override the policies that were selected above for the basic building block scope or level. And same goes for publishing. Instead of a request, though, you have a cloud event, and we can do things with that cloud event and look at its type. And if it's an important event, let's say it's something financial or payroll or something like that, we can apply very specific policies to that one. And the same with subscribe, right? So that actually takes us all the way through a full example of what that CRD could look like. And one of the things we're going to have to do is when you install Dapr now, we need sort of much like you get a default configuration that's put into your Dapr directory on your local machine, we also need a default resiliency YAML as well. And so, not to get into full details, but what this file is going to do is it's going to get installed on your machine when you do a Dapr init, and basically scaffold out as much of this structure of the configuration as possible so that you can be more productive and not have to refer to the docs a whole lot. So I already mentioned the implementation phases, and then you can't talk about resiliency without talking about how it can actually, you can actually harm your performance of your application if you're not careful. And so, you have to understand some things like, you obviously don't want to configure in the cases of like pub sub or streaming specifically, like if you miss a message and you give up on it, you've dropped that message, and that can be a big problem. You also want to avoid writing duplicate records, because what you might do is retry a message that actually already did succeed, and then you might double write it. So that's kind of saying maybe you need to implement in your own system some concept of item potency. And I also already kind of mentioned if you don't do retries and timeouts correctly, you can actually overrun your system with traffic and take it down by your own doing. And it gets into knowing a lot about your errors, right? So if I'm calling an API and I get a 400 versus some sort of non-HTTP error message, like how do I distinguish between the two? What's retriable versus what's a permanent error? And so one of the things in Dapr I think that needs to be enhanced to support this is that even at the component level, perhaps the components need to provide a little bit more meta information to make this distinguishing decision here to say, like for a record, is it just not found? If it's not found, I shouldn't retry that anymore. But if it's an internal server error, maybe I should retry it because it might go to a different node or what have you and actually succeed the next time. So there's all these considerations that need to be pulled into this as part of the implementation work. And a lot of that has to do, this is kind of a Go comment at the end, is some of our components take context all the way through the call stack, some don't. But in order for this to work kind of end to end, some of our components are going to need to actually pass this around and make use of this a little bit more. So this is just thinking ahead a little bit, probably a little bit more prematurely than it should be, but this is just thinking about the possible things that could be challenges in terms of implementing this. So I will stop there. And I think we need to move on to the next topic anyhow, but I'm gonna go ahead and stop sharing. If there are any quick questions, or Nick, did you see any questions in the chat that we needed to address, or should we move on?
I think there was a couple questions in the chat, but I think your own was on top of it. So I think we're good. I don't see any new ones.
All right, good stuff. All right, thank you.
Okay, can everyone see my screen? I don't have the little green border.
Yep.
Okay, cool. So now we're gonna move on to talk about an upcoming feature, which is support for Unix domain sockets. We're gonna hand this over to Long. Unix domain sockets really enables a performance boost when an app calls into the Dapr sidecar. And so I'll leave it to Long to explain that scenario in more detail and hopefully show us an example of that working.
So can I share my screen?
Yes, please.
Okay. Yeah. Could you see my code?
We can. Can you zoom in a little bit, please?
Sorry, I cannot see my screen, so just check. Yeah. Could you see my code? Open
Yeah,
terminal.
we can see it. Can you zoom in a little bit?
Okay. Just a minute. Uh, quick. Okay. Sorry that. Wait a minute. So sorry, I do not look, found a good place to load it.
Okay, it's fine. You can continue.
Your the Unix domain socket is provided by kernel to support two process on the same host to communicate each other. This is more perfect. This call this they do not like a local host. This is use socket to communicate and spend this is more perfect. This has better performance than local hosts, and in fact, this bypass TCP/IP stack. So this is his advance, and also if with the Unix domain socket, we can connect it to the site client directly or by other users, not like the local hosts. We cannot use it with local hosts. So here, for now, the Unix domain socket has supported in the runtime and in the CLI. Here is a way. It's a way to use the CLI with simplify the Unix domain socket pace at the tempo, and this will connected the socket in this in this in this directory to collect it. I just read this in the I just read this with Go SDK, and this PR is is on the review, and now we can see this uh, in the old one is use port, and now we can use with socket. I just change the hello world example with socket, and we can say go. Yes, this will run all the application and with 100 times, and we can spare the time to see this performance. This is every time. Maybe has some flow. But if you run more times, the this shows that the socket spend less time than the local host. This is his advantage. So that's my demo share is end.
Okay, I think so. Archer said this would be great to put this into the perf tests. So something that we should definitely consider. Not seeing if there's any other questions. And thank you, Long, for showing that and for working on that feature.
Hello?
Yep, Archer, go ahead.
There is another benefit of this feature, which when Long was showing the example using Unix domain socket, he did not have to hard code the port for Dapr. So if you're running multiple applications on a local development with Dapr, you don't need to worry about which port goes to which app. Everything is handled automatically by the socket path, because the socket path includes not only the directory, but also the app ID as part of the file name. So it becomes a unique reference. So you don't need to worry about, okay, this app and this other app running Dapr conflict with the port. You don't need to worry about that anymore. And the guessing game is over for local development.
Yeah, this is really important. It's also important to note out that this isn't usable via Kubernetes. So this is currently only supported for the self-hosted mode. And we really want to add support for configuring this on Kubernetes too.
Sorry that the Unix socket support is bad on Windows. Yes, we have skip Windows. If any users and if any users use Unix domain socket on Windows, we will print error and skip it.
Yeah, that is true. Windows support is another limitation for this feature. Yes.
Okay, I don't see any other questions in the chat regarding this. If there are any, please feel free to enter them in. Otherwise, let me go back to the screen. And it looks like we have come to the open discussion segment. So this is a time where if anyone has any questions, Dapr related or anything that we have seen tonight that you want to dig a little deeper into, now is definitely the time. And you can ask to be unmuted and I will unmute you. Okay, I don't think I'm looking, so I'll give some folks some time to type their questions or to think their questions if there are any, but looking through the chat, does anyone, I might have missed some that weren't addressed. Does anyone see one that we should talk about? I know I'm excited that the configuration building block potentially will be released in the 1.5 milestone. So hopefully I can help out there. Sure, we have a question. Let me unmute you 1 second. Can you, Ajmal, can you try to unmute? Ajmal, I don't hear you. You can always enter your question in the chat as well, and we can try to address it that way. And I'll add that it looks like you're unmuted. We still just cannot hear you.
Yeah, Jamal, you're unmuted, so you can ask your question now.
Seems to be an audio issue. So, Ajmal, if you want to just type your question in the chat, we can try to get to it that way. While we wait, anything else from from the folks on the call? Okay, well, guess we'll give it a couple more.
Yeah, just give him a minute or so in case he's typing. Yeah, he says he has an audio issue. So you can type in chat. Or next time, okay, we can wait until next time.
Okay. Well, if there are no other questions, thank you everyone for attending the community call for November 2nd, and we will see you next time. Thank you.
Thanks, everyone. Bye-bye.